What's up guys, this is Saturday morning and I would like to explain you about the steps for Linux kernel compilations. I have seen a lot of videos explaining about kernel compilations, but I don't find a single video where it explains in details about the different options. Most of the time they stick to just saying make menu config, make busy image, make install, that's all, or probably after that make init rd. But I would like to go and into a little bit more details and make a single comprehensive video so that it's useful. So before we go ahead with the kernel compilation, I would like to tell you certain things. First, whenever you are compiling a kernel, you always have the risk that you might break the system. So never try onto a development machine. Get some old hardware or maybe any machines lying idle if you can lay your hands on, and try to make a kernel on that. The other options which I use is using virtual machines. So virtual machine is safe in the sense even if it gets corrupted you can always have the new virtual machines. And virtual machines has the advantage that you can take a snapshot, and in case if it fails to boot because of any reasons in your grub, bootloader, or maybe the kernel itself, you can always restore from the snapshot, and it takes like within few minutes your system is into the same state. So this is my virtual machines running on Mac VMware Fusion. So let's go to the virtual machine settings. So in the virtual machine settings you have these options called snapshots, and you can say click take a snapshots. Once you say snapshot, it takes the current state of your machine, virtual machine, and creates a snapshot. And let's suppose tomorrow you have a problem after kernel compilation, you can go to the same option snapshot and say restore. You can choose from which image to restore. So that's about it. If you don't know how to install virtual machines, you can you can check my video Ubuntu in VMware Fusion, or it's almost the same step. Fedora also you follow the same steps how to install on VMware Fusion. Maybe even on Windows this will work. It's almost same. You have to explore a little bit. So that's about it. Now let's go to the real part. So whenever you are trying to compile a kernel, you have to first download the kernel source code. The kernel source code could be found from the website kernel.org, and kernel.org has this listings for the different type of images versions. Basically you can download one of these mainline tar.gz image. You can click on this and it will download, and you can untar and we can proceed, but we will not do for that. The reason being 3.18 is kind of stable, not it's stable but it's a mainline. Stable is 3.172, but it is pretty stable I would say. And for development purpose, like suppose you are applying some patch, you are making some changes to the kernel and you want to submit to the kernel community, so you always want to be on the latest. Mainline is not always the latest. So now there is Linux Next, which is always the latest, and it is used for development purpose from the Linux community. Most of the new changes first go to the Linux Next. It is stabilized over a period of time, go to the mainline. So now Linux Next, if you choose, the problem is it might not compile. Depend upon the compiler options might have changed or something has been changed, so you never know, and it might break your system. Your system may not boot despite compiling everything, so because it's not very well tested. Now if you use mainline, that is equally good, but you will not be able to use git to submit your patches or to make changes. So that's why you use mainline, but not from as a tar file but using a git utility. So now how do we do that? You go to https here, you go to the browse options here, and then you have the link for the linux.git. So for the mainline, this is the git link. So click on this link and scroll to the bottom. You will see the actual complete URL for the git. So do a copy of this. Let me see my video, because last time I stopped my video recording because of any reasons, so I don't want to do that. I don't want to re-record. So copy that and go to any of the folders where you want to download. So I don't have anything, so I will say git clone and followed by my paste. And once you do that, your git will try to download all the object files, which is basically nothing but the source code compressed as object file. but I already have it downloaded. I don't want to waste time, so let me quickly go to the place where I have already downloaded. So this is the place where I have downloaded all the my kernel source code, and we are going to start building from here. Now I would like to tell you something about building the Linux kernel before we start into the actual building. So to build a kernel, there are two things. One is the kernel actual image, and then the modules. So as you might be aware by this time that there are modules and then there is an actual kernel. The kernel is mostly like monolithic. It has all the stuffs which are necessary, and modules are like runtime extensions to the kernel which you insert into the kernel, and that becomes a part of the running kernel. So that way it gives a flexibility that Linux kernel, even though being monolithic, is not exactly monolithic. It's monolithic plus modular because you can extend the features of the kernel. Now all configurations and features of the kernel can't be as modules. Let's suppose if you take the networking stack cannot be compiled as kernel modules because TCP/IP stack is needed by the kernel for the correct functionality, because many of the networking drivers are controlled from the kernels. Now similarly, like for the file system driver, that might not be compiled as modules, even though file systems like DOS, NTFS, those can be compiled as modules, but not the file system core driver. That has to be in kernel, that has to be present, because Linux kernel is based everything on file system. So that's the two part. One is making a kernel, which is a kernel for the image, and then the modules for all the other things. So you have to do two steps. Now before we go ahead and do that, I would like to point out some more stuffs about different configurations of the kernel. So you have to select which all stuff you need to select as a part of in kernel or as part of modules. So to do that, what you have to do is you have to create a config file. That config file you can borrow from your old system, so, or you can just run make old config. So what make old config does is it takes your old configurations from your /boot partitions, and wherever it has some doubt it will ask you. So it will ask you like options like this. So if you just press enter, it will select the default. The default is yes here, or you can press yes, or if you don't want you can say no. So that's the way you create a configuration file from your existing kernel. So where is this existing configuration file is present? If you go to /boot, in /boot you have this config file already present. So this is configuration file for 3.11.10, this is for 3.15.10. so this is just a plain text file. That's the way it picks up. Now we will not do old config. The reason we will be creating our file from scratch, but I would like to give some more options, like what all the options are there in the config file. So now the other options you have is you can say make config. It's a text based and it will work only if you already have a configuration file. Otherwise it keeps on asking you for all the options. You see, I give make config and it asks me for the options. So whenever you are developing for company or something, and if it's the automatic build is trying to build a kernel, there is no one to enter this inputs, so you already need to have that file present. But make config is good when you're creating by hand, but it's like kind of tedious. If you see this, the kind of options it has, it's like mind-boggling, and you have to select each of these, and it has to be the right options. You don't want to miss a driver, your system might not boot, so you will not go for these options. But it's good, make config is good when you already have a .config file. Right now we don't have anything, so that's the reason it is asking me. Once I have it, it will not ask me for anything, it will just go ahead and build my kernel. Now the other options I have is make menu config, but I'll come to that later. I would like to give you one more options. There is called gconfig. Gconfig is based on GTK, and you need to have the GTK installed. I don't have it installed in my system right now, so it will give me an error for GTK, but if you have it you can explore that, make gconfig, but that's not needed. Then you have make nconfig. Nconfig is again text based, but it's like slightly better in terms of it will give you a color, and you have an options, two beautiful options to select using up and down arrow key. So this also we will not explore for the time being. but you can go ahead, you can select something and do some modifications. Will come later, but we will not go for this also now. So we'll exit this and I will say don't save, and it says no save. So now there are several other options. One is make def config. So what is def config? Def config will take the default settings similar to your like make old config, and it will look into the current architecture and it will try to assign a default configuration, like whether your system is a 64-bit, what kind of file system do you need? Do you need ext3? Do you need ext4? Do you need btrfs file system? So those kind of decisions it will take automatically for you. Then the next option is make all yes config. So what this exactly does is it will select as many options as possible. So in your configuration files you have tons of drivers, like drivers from all the components, most of the components for videos and PCMCI card, USB, USB 3. So it will try to select as much as possible as yes if the hardware supports. If you're, let's suppose if you have a 32-bit architecture, you cannot compile a 64-bit driver, so it will definitely, it won't be able to select. So those kind of decisions it takes, like if it is possible make it yes, if no then okay, no problem. Then the other thing is make all mod config. What this guy does exactly is that it will try to make all your configuration as much possible as modules. So what that it means is your BZ image, your actual kernel image will be small, but your AnyTrimFs would be bigger, because modules goes as your AnyTrimFs. Most of the modules are bundled as AnyTrimFs. So that AnyTrimFs will increase in size and your BZ image will decrease in size. Make all mod config. Then the other option you have is make all no config. What this does is it will try to make as many possible options as no, which means it will not try to select for the drivers for which you don't have any device. Let's suppose you have a parallel port driver but you don't have any parallel port device, it will make it turn off. By default it's off, but you can make it on, but this guy makes sure that you turn all of those things. Then we have these options as make rand config. This is mostly for testing purpose for kernel testers, those who are trying to make a new kernel, build a new kernel and testing different options. So they can make automation for this, and what this will do is it will randomly select what all configurations to pick. So again, not very helpful for our purpose. Then we have make local yes config. So what this guy will do is it will try to make all the options as in kernel. So when it's in kernel, so that means your kernel size, your BG image will increase in size and your module size, any AnyTrimFs size will decrease. So remember, this is the opposite of make all mod config. So this is opposite of make all mod config. In make all mod config, you make as much as module as possible. So in make all mod config, you increase the size of modules, AnyTrimFs, and decrease the size of Linux kernel. But here you make all of them as in kernel. That means you increase the size of Linux kernel, which is BG image, and you decrease the size of make modules. So these are the different options which I would like to explore, and it's good. You can go ahead and explore, play around. If you have a virtual machines, you are never afraid of doing anything like that. You can always restore if your system gets screwed up. So and you always have to run it as a root when you are compiling, and probably mostly like when you are doing a module installation. So that's good, you are not limited by using sudo all the time. Yeah, sudo is also good, but in Fedora I use most of the time just root account. And this tutorial is mostly for Fedora, but you can also use for Ubuntu. I will tell you some of the differences when it comes to Ubuntu. So let's go to the real stuff now. So first confirm that we don't have any .config file. We'll start from scratch, and I don't have anything like config file. So when we will say make menu config, and in make menu config, once you run this, you save this, it will automatically take all the default and create a configuration file from you. Optionally, if you already have a configuration file, you can load using load, and you can give the name of the configuration file, and that configuration file will be loaded, and then you can do further modifications on top of that. So you can take an old configuration file, load into make menu config, and then on top of that you make some modification. I don't want to do any modification because I don't have any file, so I can press escape and come out of this. So file doesn't exist, it's not coming up unfortunately, so I can say okay, make all config, and so I say press escape twice, I come out of that. So now we will create a configuration file. So two things, I always turn it on, probably it's good for you guys too. So in enable loadable module support, I always say force module loading. So what this means is that sometimes even if the license of my module is slightly different, and it complains about tented module, I can force it to install. This is a force, but it's not necessarily that the kernel will always agree. It will always install your modules. If it is like version is mismatch, it checks and takes the action. So forcing does not mean it will be loaded automatically. Then the next option which I always turn it on is in file systems. If you scroll down by up and down key, there is a DOS, FAT and NTFS file system. And here I always try to turn on my NTFS file system support, because in my Linux machine I would like to use some of the hard drive which are NTFS formatted, so I always try to turn it on. So you see there is this options M. M stands for it will be compiled as modules, and if I press spacebar, it will toggle between M and star. What star means, it will be compiled as in kernel, M means modules. Now, not all modules can be compiled not everything would be compiled as modules. Like I said, network drivers, you cannot select it as modules because that's very much needed. And similarly here, see, NTFS can be compiled as a module, but not NTFS debug support, because it might be needing some features from the kernel, so either you turn it off or you turn it on, but you cannot compile it as modules. So I would like to have it as in modules only, as in kernel only, and you say select, and I can say exit. So before we exit, I would like to show you one more thing. If you go to the general setup, so there is a local version. In this local version, if you select this local version, and you can type a string like what is the version which you want to name your kernel as. It's good for identification purpose, but it's not necessary. For my kernel, I will just say shekilk1729 as an identifier. Then you have one more option called automatically append version information to the version string. So if you are using Git, and if you select these options, it will pick up the version from the Git for the Linux kernel, and it will append to the name of the kernel. If you're not using Git, probably it might just append the version, and it's okay. Even if you don't select these options, it doesn't matter, but I just select it. I like it. And then you keep on selecting yes and exit. So let's go and look for my config. Now my config file is already being created, and you see this local config version. I gave the version as shekilk1729 as a string. It has come up here, and you also see that I have selected local version auto as yes, which means it will append the Git version. Since I'm already using Git for the source code of Linux kernel, it will append a version from the Git to my Linux kernel image. So that's all. So now once this is done, I will proceed with compilation of my Linux kernel. So Linux kernel, whenever you compile, the kernel image is a compressed image. The kernel is compressed using several of the algorithms. It supports like gzip, bzip2, lzma, xz, lzo. So when initRD loads the kernel, it notes which format it is compressed. It can look into the header as a magic file, and it can try to do uncompress based on that header. So now we will proceed with the kernel compilation. So most of the compilation from the make file is like sequential, but there is an options in make that you can make it as a parallel compilation, and of course the make file has to be written in such a way that parallel compilation is supported. So fortunately Linux kernel supports parallel compilation using GNU make, which has the options -j. So if you want to compile just the kernel, you have to say make but you can also give make bz image. That means it will create a bz2 compressed image. So it will say make bz image, and you can give an options -j2. That means two parallel thread will run. So two can be space or without a space, it's okay. So two threads of compilation will run for this bz image, and it's always best to give twice the number of cores as your thread. So let's suppose how many cores I have to check. So proc CPU info, I can see that I have processor 0. So I have one processor, I don't have processor 1. Had there been two cores, it would have listed processor 0 then processor 1. Since this is my virtual machine, I have allocated just one CPU, so for me it's just processor 1. So if it's one processor, so I can say make -j2. So for one processor, two threads. For two processors, four threads. So that's the best option, and you say make bz image. So this will create my Linux kernel, just the kernel, not the modules. It will create my one. And if I want to create modules, I have to say make -j. Again, j2 is for threads, number of threads, and make modules. This will compile my modules. Now I don't want to do one after the another, so I will tie both of them together using make bz image, and I will say and make modules. So what and does here, let's suppose if my bz image compilation fails because of any reason, my make module will not proceed. So it's an and operation. Had I given or, so even if bz image fails, it will go ahead and do a make module, which doesn't make sense. If there is a problem in your kernel compilation, you cannot do anything with the module. So I give and. So, and with make modules also, I'll give options -j2 for two threads. But I have seen that for me, like 4 thread gives the best timing, best options. So I will put 4. And I can also give a time here, and what this basically means is how much time it takes. It will print at the end of this entire compilations of my bz image, which is my kernel and my modules. And let's start. So it starts compiling my kernel, and we will be back once it is done. I'll pause the video and we'll proceed after that. So guys, we are done with the Linux kernel compilation, and you can see it took me like 9 minutes and 40 seconds to do the entire compilations for my kernel and modules. So we are done with that. Now it's time to create my AnyTrimFs disk, load the kernel and boot from it. So Fedora has different options to create AnyTrimFs. First, I would like to tell you some of those things. It has like initRD, then AnyTrimFs, and then there is a drawcut. Before we go with the drawcut, I would like to tell you the difference between AnyTrimFs and initRD. So I would like to write it here. So one is AnyTrimFs, the other is initRD. initRD is a older thing. It has some of the weaknesses which AnyTrimFs overtook. So what are those weaknesses? One is initRD needs to have at least one file system driver compiled into the kernel. If it is not, like let's suppose at least one, like ext3 has to be compiled. If not, it will not work. AnyTrimFs doesn't have that weakness. Second thing, initRD needs to be of fixed size, and AnyTrimFs can be extended, so it need not be a fixed size. So that's the another advantage of AnyTrimFs. And the third is initRD does a lot of buffering into the main memory. It consumes memory. That might not be that much of disadvantage, but yes, like where memory is the constraint. Sometimes if you want to compile your kernel on a limited memory on an embedded platform, like on a BeagleBoard itself, you want to compile a kernel, then those things helps. So we will be using AnyTrimFs. Now drawcut is a new tools which has some of the good options in terms of scriptings and a more polished way of creating a AnyTrimFs. So you can either use AnyTrimFs or drawcut. So that's already in my path, and AnyTrimFs is also
Imagine the luxury.
So and then there is this AnyTrimFs. So I don't have it because drawcut is internally using, I believe, AnyTrimFs. So what you say is drawcut -f F stands for force. So even if you have that AnyTrimFs file already in place, it will try to remove it or overwrite it. And in the boot folder, I will create one file called AnyTrimFs. I will rename this later, but I will say just AnyTrimFs. And here I have to give a kernel version. Now before I go ahead and give the kernel version, I compile the modules, but I have not installed it. So I have to do that first. So what I need to do is I will say make install. And what make install will do is make install will copy my current BZ image and put it into /boot folder. So let's go to /boot folder first and say ll. You see there is no AnyTrimFs or there is no BZ image in this folder. So I will say make install. And what this guy does is, so you don't worry about lib modules dependency for the time being. It will not cause any problems, but yes, we have to fix that because it just creates a kind of dependency. If it doesn't find any dependencies, it will give a problem, but nothing to worry about that. Now let's go to boot folder again, and if you come here and you see here, so it has copied my Linux kernel, which is VM Linux. So it has copied from the BZ image. If you see the size 587912, so it has copied it here. This is my BZ image. How do I know that this is the image? Go back to the folder where I have compiled, go to arc x86 boot folder, and here you will see a BZ image. See 587912, and this is what I have in /boot folder VM Linux. It automatically renames it 3.18. You see this 587912. Alternatively, instead of running make installed, you can just copy this file, make BZ image, and copy it to your /boot folder. So you can do that. Now then the next step is you have to say make modules underscore install. So whatever modules you have built, you have to install it into a folder so that at runtime those modules are available, as well as at boot while creating your AnyTrimFs, you need to have these modules present. So it says no make module because I'm in a wrong directory. I have to be into the root folder of the kernel compilation, so I have to be into this path, not there. Let's say make modules underscore install, and it has done the installation of the module. So how do I verify that? You go to lib/modules now, and if you see, this is the modules which has been added to my existing lib module. So lib module is the place where all the modules are placed for all the previous version. So now I have to create a AnyTrimFs. So then I say is dracut -f/boot, and the name of my AnyTrimFs, I will just name it as AnyTrimFs. I will modify it because the name has to match, like 3.18 something something blah blah blah. So the name has to match. So I will just say for the time being like this, and then followed by my image name. So this is the way you create a AnyTrimFs. So in the boot folder I will see a file called AnyTrimFs now once this is done. So it will take some time, not much, maybe 2 minutes to 3 minutes, even lesser than that. Okay, it took less than that. So you go to /boot, and here I have this AnyTrimFs. So now if you see the name of the AnyTrimFs, it has already created a AnyTrimFs like this for me. So it's the same AnyTrimFs, but I can use this AnyTrimFs, or I can use this AnyTrimFs which I have built just now. So when I did a make module install dracut already using dracut, it has already done this. So I can ignore this, but if it is not doing this for you, like if you're just using plain old config file, then you can rename AnyTrimFs to this guy. So the reason you want to name AnyTrimFs like this is because when you're configuring your grub looks for certain sequence, like it looks for the extensions img and name followed by AnyTrimFs. If your name does not start with AnyTrimFs, it doesn't picks up. That's with the grub too, but with grub it picks up without those names. So now having done that part, and we will be modifying our grub. Now to modify the grub, most of the system nowadays comes with grub2. So what we have to do is we simply have to say grub2 -mkconfig. This is already should be present, -o, and then followed by /boot grub to grub.cfg. Now if you see, it will generate a new file. So if you see that your each VM Linux and AnyTrimFs should be matching. You see 3.18 RC3 Sekil 172.900, this is and this is matching. My older version of kernel, these and these are matching, these and these are matching. Let's suppose if your AnyTrimFs is not matching with this, your system will not boot. So my kernel has been compiled, my grub has been loaded, I have created the AnyTrimFs, everything is now done, and I will reboot and I will select my new kernel as 3.18 and I'll boot that. So let's reboot my kernel now. So I'll stop the video while it is booting and then we'll come back here.